These were the three cases we looked at in the previous video. In every case, we had to prove that angle AOB measures twice as much as angle AEB. In the first case, ACB was a minor arc. In the second case, it was a semicircular arc. And in the third case, it was a major arc. We proved the result for the second case. Let's try to prove it for the first and the third cases. For now, let us prove the result for the first case. This is the figure we have for the first case. We consider a minor arc, which is this green region. We are given that angle AOB is the angle subtended by this green arc at the center. And angle AEB is the angle subtended by the green arc at any point in the remaining portion of the circle. So we have to prove that measure of angle AOB is twice the measure of angle AEB. Look at the figure we have with us. How do you think we should proceed? You're right. We do not have any information with which we can proceed towards the proof. So we have to do a bit of construction. First, we need to join points A and B to form chord AB. One way in which this construction helps us is that it gives us two triangles. Next, we draw a ray from point E crossing point O, and let's assume it meets chord AB at point F. So we draw a ray like this and name this point F. Before we get to the proof, we need to understand one simple concept. The concept of exterior angle of a triangle. Consider this triangle in which one side is extended to be a ray. Let angles 1, 2 and 3 be interior angles of this triangle and let the exterior angle be 4. The exterior angle theorem says that the measure of the exterior angle will equal the sum of its remote interior angles. Angle 1 is the interior angle that is adjacent to the exterior angle, and angles 2 and 3 are the interior angles that are remote. So angle 4 will equal angle 3 plus angle 2. Let's erase this. Now look at triangle EOB. Angle BOF is the exterior angle, and angle OEB and angle OBE are the remote interior angles. According to the exterior angle theorem, angle BOF will equal angle OEB plus angle OBE. This was our first result. Now let's focus on triangle EOA. Angle AOF is the exterior angle, and angles OEA and OAE are the remote interior angles. Using the exterior angle theorem, we can say that angle AOF equals angle OEA plus angle OAE. This was the second result. Now let's shift our focus back to triangle EOB. In triangle EOB, OE and OB are equal because they are the radii of the same circle. It is an isosceles triangle, and by the isosceles triangle theorem, we can say that angle OBE will equal angle OEB. We can write ITT here to show that we got this result using the isosceles triangle theorem. Similarly, as triangle EOA is also isosceles, angle OAE will equal angle OEA by the isosceles triangle theorem. Look at the right-hand side of the first equation. It's angle OEB plus angle OBE. But we just found out that angle OBE equals angle OEB. Substituting this in the first equation, we get angle BOF equal to twice angle OEB. We substituted angle OBE with angle OEB as they are equal. Similarly, substituting the value of angle OAE in the second equation, we get angle AOF equal to twice angle OEA. If we add these two equations, we get angle BOF plus angle AOF on the left-hand side. And as we have 2 as the common term on the right hand side, we write it as 2 multiplied by angle OEB plus angle OEA. Now let's look at the figure again. Angle BOF and angle AOF together form angle AOB. And angle OEB and angle OEA together form angle AEB. From this equation, we get angle AOB equal to twice angle AEB. Remember, the angle subtended by an arc at the center is twice the angle subtended by the same arc at any point on the remaining part of the circle. We proved this result for the first case, where arc ACB was minor. This result is the same for the third case as well, but just a small change in the final line of your proof. The angle AOB we see in here is a reflex angle, which means it is between 180 and 360 degrees. So when we say angle AOB, it can be confused with this red angle, while the angle you're looking at is actually the green one. So in your final line, instead of angle AOB, you will need to write reflex angle AOB is equal to twice angle AEB.